This is 1, 2, 3, 4, 5. That is 5, and this one is 11 because from here, the length from here up to here is 11. So we are going to say 5 times 11. So 5, let me say 11 times 5, which actually gives us 55 square units. So that is area of the whole region. But now we can get the area under curve. This area under curve y equals to x squared plus x plus 5. The area here, if we subtract it from this area, which is the one for rectangle, we are going to get this shaded region here. But now we are supposed to use trapezium rule to estimate that area. And according to trapezium rule, we know, let me draw the trapezia. The first one is here. The second one is here. The third one is here. The other one. So we know that the first boundary here, if I connect this point here to make a trapezia out of it, it's going to be this way. So I'm trying to form the trapezia. In this case, we know we label them y0 for trapezia, y1, y2, y3, y4, y5. To be labeled, they are 0. Now for us to be able to get these values of y, we have to be able to draw the table, because we know that the area here, area using trapezium rule, will be half h into y0 plus y5, the other one, plus 2 into y1 plus y2 plus y3 plus y4. That is going to give us the area of this trapezium, half h here, sorry. There's a half h there. So we know that for us to get h, we say that h equals to b minus a over n. And b in this case, we know that the lower limit is a and the upper limit is b. So the lower limit, the upper limit is 2 minus lower limit is negative 3 over n, where n is the number of trapezia. In this case, we have been told there are 5 strips. So divide by 5. So 2 minus 3 is 5. Divided by 5 is 1. So the height here is 1. So after getting that height, what I want us to do is to get a table so that we can get these values of y0 to y5. We know the function is y equals to x squared plus x plus 5. So this is y, this is x, this is y. 1, 2, 3, 4, 5, and 6. So the first y we are going to get when we substitute negative 3. So what I'll have here is if x is negative 3 here, negative 2, negative 1, 0, 1, 2. If I substitute 3 in that equation, negative 3, it will be negative 3 squared plus negative 3 plus 5. That is giving us 11. So 11 there, when we have negative 2 squared plus negative 2 plus 5, we get 7. 7 here, and then we have negative 1 squared. Viewers, you have to just do this thing using the calculator. That's why you have a calculator. Don't assume that you do it often. You may meet a problem. Then when x is 0, this will be 0 plus 0. This will be 5. So this also will be 5. Then when it is 1, that is 1 squared plus 1 plus 5 is 7. And probably that could be 2. 2 squared plus 2 plus 5. That is 11. So those are the values of the boundaries of the strips here, or in other words, the parallel sides of this particular equation. So we know that we have determined the formula for this one, the area as A equals to a half h, this is the trapezium rule, into y naught plus y5 plus 2 into y1 plus y2 plus y3 plus y4. That is going to give us the area of under the curve, this curve here, this area below this one, below the shaded region. We have determined h as 1. This is where we determined h. H is 1, so times 1 here, into y naught is here. So y naught is 11 plus another y naught is at 2, which is 11, plus 2 into the ones at the middle is 7 plus 5 plus 5 plus 7. So if you simplify this, 1 times half is just a half, into 22 plus. So we know that 7 plus 5 is 12 times 2, because we have 12, then times 2, 48. So this will give me A equals to a half into 48 plus 22, 70, divided by 2, 35. So if I do everything, I'll get 35 square units. This is not the final answer. This is just the area under this curve. But I said that the area of the rectangle was here 55, from here up to this one here. For us to get the shaded region, we are going to subtract 55 minus 35. So the area of the shaded region that we want here now, answer now will be 55 minus 35, which is 10, not 10 but around 20. 55 minus 35 is 20 square units. So 20 square units. So this is the answer, the estimated answer, because we know when we use area approximation, we are actually estimating the area. So this is how we determine the area using trapezium rule. Now the second question B is telling us to be able to use, find the exact area. To find the exact area, that is question B now, find the exact area bounded by the curve y equals to x squared plus x plus 5 and the line y equals to 11. So viewers, when you see a question like this where you are asked to determine the area bounded by the curve, the exact area, and the word here is exact. The word there is exact. When you hear the word exact, it's pointing you towards integration, because only integration can be used to get the exact area under the curve. So in this case, we are going to use integration. I want you to believe that the first question could give you up to 4 marks. 4 marks. The second equation here, we are also going to earn 4 marks, and then part C is going to give us 2 marks. So this one here, we are getting exact area, and I know that first I'm going to follow the same thing I did by getting this area of rectangle here. So area of rectangle, that is not estimated, it's just going to be very exact, of rectangle. We know is equal to 11 times 5 because a rectangle, that is 55 square units. Now area under curve, area under curve. Area under curve, you have said we are using integration to get it. So what we are going to get, area under curve, will be given to us by the lower limit is -3, the upper limit is 2. So 2 here, -3 into the function is x squared plus x plus 5. This is what we need to do to get the exact area under curve. So we know if we integrate this part here, if we integrate x squared, I add 1 there, it will be x cubed over 3, so a third x cubed plus, this is 1 plus 1, 2, so a half x squared plus 5x plus c. But I said that in this case we don't need to write c because c will actually self-eliminate. The upper limit is 2, the lower limit is -3. Remember that if this area here is positive, the curve is positive, it's above the x-axis, all of it, so we don't have to separate it. But if at all one part was below and one part is above, you have to do this thing differently. So once we have this particular issue here, what we need to do is to substitute 2. And when we substitute 2 there, it will be third into 2 cubed plus a half into 2 squared plus 5 into 2 minus a third into -3 cubed plus a half to -3 squared plus 5 into -3. So viewers, we move to the next step here. Let's substitute, let's get all this one. That is 2 cubed over 3 is going to be 8 over 3 plus, this is 4 over 2 is 2 plus 10. -3 cubed is -27, divided by 3 should be -9, plus, this is 9 over 2. 9 over 2 minus, let me write it again here so that the space can be enough for me. This is 8 over 3 plus 2 plus 10 minus -9, you said -27 over 3, this is 9 over 2 minus 15 times 3 is 5 times 3 is -15. So here 8 over 3 plus 12, that is going to be 14 and 2/3 minus -15 minus 9 -15 minus 9 plus 4.5 plus 4.5 is 19.5. So if we have 14 2 over 3 minus answer, we get 34 and 1/6 square units. So that's the area under curve. Now if you are asked to get the area of the shaded region, forgive me, I want to come finish that part up here. Area of the shaded region, in this case shaded region, will be the area of the rectangle, which is 55 minus 34 and 1/6. So if I do that, I'll get 55 minus answer I get 20 and 5 over 6 square units. Now this is the answer for the area under curve using the integration, the exact area. We realized that the answer we got before was 20. So it means that if you look at now whether a trapezium rule is overestimated or underestimated, we can see that the trapezium rule underestimated by around 5 over 6, because this is the exact area which is bigger than the estimated area using the trapezium rule. So we can actually say that trapezium underestimated this particular area here. Now the final answer, the final question which will give us 2 marks, the final question, which is part C, is to calculate so question C is to calculate the percentage error. Calculate the percentage error that arises or that occurs when the area is estimated by trapezium rule. Now, the same area we are looking at is this one. We have said that we have the exact area, the actual area is here. The estimated area was 20 square units. Now what we need to understand is that if you, in Form 3, you also learned about approximation and errors, where you are looking at the upper limit, the lower limit, the actual and whatever. We know that for us to get the error, this one is now what we are going to call the relative error. Relative error in this case should be, in this case, it can be actual minus the lower one, or it could be the opposite, based on which one is bigger. In this case, the actual area is the bigger one, and the estimated one is lower. So we're going to have this 20, 20, and 5 over 6 minus 20. This, the actual area is bigger, and this is the estimated area, which is smaller. If this one was bigger, I would have subtracted the other way around. So what we're going to find out is that the difference here is just 1 over 5 over 6. The difference is 5 over 6 square units. But we know we need to calculate the percentage error. So percentage error is going to be, this should not be a relative error, it should be absolute error in the area, yes. This one should be absolute error. The relative error here should be, the actual, the error, absolute error in the area over actual area or exact area, let me write exact area, times 100%. So the error here is 5 over 6 divided by actual, which is 20, and 5 over 6, everything times 100%. So what we are going to do is, if we have 5 over 6 divided by that times 100%, what I get is 4%. What I do, that is 4%. What I do, I get 5 over 6, the calculator, that is, we do it again, 5 over 6 divided by 20 and 5 over 6. If we do that, we get 1 over 25. So 1 over 25 times 100%, we get 4%. So it means that the error that occurred by estimating this area by using trapezium rule is 4%. And we know that that 4% is not overestimated by 4%, it is underestimated. So we can actually show that. We can say that this one is underestimated. Underestimated by 4%. It could also be overestimated by 4%, but in this case it's underestimated by that percent. So you realize that this question is combining many ideas together. One is shapes, area of plane figures, like in this case we use area of a rectangle. That is learned in Form 1, I think so. Then the second thing we are also going to look at is area under curve, which is done under trapezium rule, and also area under curve, exact area under curve using integration method. And then we looked finally at errors and approximation, that is done in Form 3. So realize that this thing is collecting very many things together, that if you don't know one, then assuming you didn't know this part C, you don't know how to get percentage error, then it means you could only score the 4 marks for part A and part B. Part C will be missing there. And what about if you don't know the area of the rectangle? Then it means you can simply be able to use what we call integration to get this one, or maybe go for trapezium rule again for this one, which will take more time and also more space. So realize, learners, that in mathematics Form 4, for you to be able to succeed in this KCSE questions, you need to master almost all concepts, because some of them will depend on each other for you to be able to solve a problem. Let us look at example 2. Now, viewers, this number 2, the diagram below shows the curve of the equation y equals to half x squared minus x plus 3 for 0 is less or equal to x, which is x which is less or equal to 6. So we are told to calculate the mid-ordinates for 5 strips between x equals to 1 and x equals to 6, and hence use the mid-ordinate rule to approximate the area under the curve between x1, x equals to 6, and x axis. So area under the curve, this is the curve, but the boundaries is x equals to 1 to x equals to 6 there. That's what we need. We need to get the area here, under this region here. We know we need 5 strips, so if you need 5 strips, these are the ordinates. These are the ordinates. But the question here wants us to be able to calculate the mid-ordinates. So if you ask to calculate the mid-ordinates, which are actually, let me draw these ones to be continuous lines. To drawing these lines, these are the ordinates, but the question wants us to determine the mid-ordinates. Now I'm going to show the mid-ordinates as broken lines. So this is the first mid-ordinate, this is the second mid-ordinate, this is the third mid-ordinate, this is the fourth mid-ordinate, this is the fifth mid-ordinate. Now if you are estimating the area, we know what we need to draw with the mid-ordinates to show how the area will look like. How the area will look like. We can even tell whether we are going to overestimate or underestimate, although sometimes it's hard to tell. So this is how the mid-ordinates will show the appearance of the diagram. There. So we have here the shape of the diagram the way we'll see. You see, this one are overestimations. These ones. These are underestimations actually. These ones here. But these ones are overestimations. So we are going to see how that plays out. This is the first bar, or the first rectangle, the second rectangle, the third, the fourth, the fifth. We are also told to refer to them as strips in this particular equation. So for us to find the mid-ordinates, we just have to draw a table here of the mid-ordinates. And in this table, this is y, 1, 2, 3, 4, 5. So this diagram here, when x, the first mid ordinate is here, this should be 1.5. This one here should be 2.5. This should be 3.5. This should be 4.5. This should be 5.5. You realize that if you have h, where we know that h is equal to b minus a over n, and in this case b is the upper limit, which is 6, minus the lower limit, which is 1, divided by 5, which is n. This will be 5 over 5, which is 1. So if you determine the first mid ordinate here as the value of at x equals 1.5, the next one will be this one plus h. So for us to get the next number, you'll find that you are going to get the first mid ordinate, which is this particular point. If you say 1.5, so this is the first ordinate. The second ordinate will be this one plus h. The second one will be 1.5 plus 2h. The third one will be 1.5 plus 3h. 1.5 plus 4h. And then here we have, this is the first one. The first one is 1.5. So this is the first, the second, the third, the fourth, and the fifth. So if you have here in this case we have 1 times 4 is 4. 4 plus 1.5 is 5.5. If you want to get this one, it will be 1.5, which is the first mid ordinate, plus 3h. So that will be 3 times 1 is 3, plus 1.5 is 4.5. So that's how you fill them. If you can do this one, then it will be easy. Students have difficulties usually determining the mid ordinates, and there's a way to be able to determine it here, where you just need to find the first ordinate. If you can find the first ordinate, then you are right. And how do you get the first ordinate? Take this one plus this one, divide by 2. The boundaries, or the lengths, the parallel lengths of the first ordinate, which is this one is 1, the other one is 2. If you have 1 plus 2 divided by 2, you will get 1.5. From there you can now use this one to fill the rest that are remaining without even looking at the diagram. You just come and filling them there. So we have seen that this is 1.5, this is 2.5, 3.5, 4.5, 5.5. Now viewers, there's something that is very clear that students do well in trapezium rule than the mid-ordinate rule. The reason for that is because students don't understand what mid-ordinates actually are. They normally fail 1, 2, 3, 4, 5, the boundaries in the table, thinking that's the mid-ordinate. That's actually the trapezium rule. And if you fill the boundaries, you realize that you're going to have 1, 2, 3, 4, 5, 6. But in mid-ordinate rule, the number of strips and the number of mid-ordinates will be the same. If it is 5, it is 5. Trapezium rule, it will be 1 extra by 1. That's why we normally start here with y naught, so that the other side can be y 5. So let's try to substitute this one now in the equation, which we already have. So I'll say 0.5, which is a half, times 1.5 squared minus 1.5 plus 3. I get 2.625. Then what about if it is 2.5? It will be 2.5 squared plus minus 2.5 plus 3. I get 3.625. Then what about if it is 0.5 into 3.5 squared minus 3.5 plus 3, 5.625. And then 0.5 into 4.5 squared minus 4.5 plus 3, 8.625. Then the last one, 5.5 squared minus 5.5 plus 3, get 12.625. So this means we have answered the first part of the question, which is actually to calculate the mid ordinates for 5 strips. We have done it. 1, 2, 3, 4, 5. The next question they're asking us to do is to use the mid ordinates we have be able to determine here to calculate the area under curve using the mid ordinate rule. And you know the mid ordinate rule is area equals to h into y1 plus y2 plus y3 plus y4 plus y5. And you know that with the mid ordinate rule is normally said to be the sum of the mid ordinates, the sum of all mid ordinates times the common height. And the common height is h, which I said is determined by h equals to b minus a, where b is the upper limit, a is the lower limit, divided by the number of ordinates or strips. So we are, according to this case, we have h is 1 times the mid ordinates are here, which is 2.625 plus 3.625 plus 5.625 plus 8.625 plus 12.625. There we know that times 1 is just the sum of everything. So let me start. 2.625 plus 3.625 plus 5.625 plus 8.625 plus 12.625. The answer is 33.125 square units. So viewers, this is about 3 marks or 4 marks. We have estimated the area under curve using the mid ordinate rule from x equals to 1 to x equals to 6 and also the x-axis. Let us go to the second question, which is asking us to saying by using integration, that's question B. By using integration, calculate the area under curve y equals to half x squared minus x plus 3, x equals to 1, x equals to 6, and x-axis. Hence, show whether the mid ordinate rule underestimates or overestimates this area. And I estimate the area of this region this should go for around 4 marks also. So we know that, let me put aside the area we have gotten here, which is 33.125. This is the area under the curve using the mid ordinate rule. Now what you are asked to get here is the area, the actual area, and the actual area here we know that that is using integration. So the limits are 6 and 1, and the question is half x squared minus x plus 3. So if I integrate, I will say this will be, bracket is there. If I have here plus 1, it will be 3. So this will be 1 over 6. 1 over 6 x power 3 minus a half x squared plus 3x plus c, but I will not include c. You know why? By now I realize that I've gone very fast to integrate this thing. If I divide this one by 1 plus 2 plus 1 is 3. 3 times 2 is 6. So 1 over 6x cubed, half x squared plus 3x. Let's substitute. This will be 1 over 6 into 6 cubed plus, no, minus half into 6 squared plus 3 into 6 minus, what about if x is 1? 1 over 6 times 1 cubed minus a half to 1 squared plus 3 into 1. If we do that, 6 cubed to 16 divided by 6, 36, minus 6 squared, 36 divided by 2, 18, then plus 18, 3 times 6, minus 1 cubed there is 1 over 6, minus a half, plus 3. So this is what we'll get. We'll say this is just 18, that one cancel, that's 36, minus 1 over 6 minus a half is negative a third plus 3. That will be minus 2 and 2/3. So 36 minus answer is 33 and a third square units. So viewers, look at that answer. We were told to get the area under curve using the exact area under curve using integration. When we told exact, we know that it must be to calculate the exact. This one should be exact here, sorry for that. Exact area under curve. So we applied integration to get that exact area, and then that exact area is 33 and a third. But this one is 33 and 0.125. You know 33 and a third is 33.33. 33, so 33.125 as a fraction is 33 and an eighth. 33 and 1 over 8. So this is the area by middle unit rule. This is the exact area by integration. So we can say that the area integration actually underestimates. It's underestimated because the area under the curve using middle unit rule is smaller than the area the exact area by integration. Actually, if you subtract a third minus an eighth, we'll be able to get 5 over 24. So it's underestimated by 5 over 24 square units. So that's what we are told to ask there. Then the final question we are asked in this question is to again calculate the area, the error that arises. So the next thing is to calculate the error. That's part C. So calculate the percentage error that occurs when the middle unit rule is used to estimate the area under curve x equals 1, x equals to 6, and x-axis. So we have determined the area, which we know that this is the area by the middle unit rule, and then 33 and a third is the exact area by integration. So you want to get absolute error in the area. So absolute error in the area will be, we know the actual area is bigger, so we are going to get 33 and a third minus 33 and an eighth. This is the exact area which is bigger minus the smaller area which is the area and by middle-donut rule. If you subtract the 233 minus 33, 0, a third minus that will give us 5 out of 24 square units. This is the absolute error in the area. For us to get percentage error, we get relative error, which is 5 over 24. Relative error is 5 over 24, the error, over the actual, and the actual is 33 and a third. So that's the absolute relative error. For us to get percentage error, we multiply relative error by 100%. So this will be 5 over 24 divided by 33 and a third. We get times 100%. We get 0.625%. That's a good, that's better. That's much more better than what can be. The smaller the error, the better the estimation. So it means even though the actual error is still much more bigger than the estimated error by the middle-donut rule, but we can say the middle-donut rule was much more closer by just percentage error of around 0 point something. That is quite better. Not accurate, but better. Now viewers, that's the last part of this question. We just wanted to show you 2 examples so that you can see how we can apply the concepts you have acquired in the course of your syllabuses relating to area approximation, integration. And we have seen that other than that, it applies also the concept of approximation and errors way back in early stages of Form 3. Now viewers, that's the end of our lesson today. I want to welcome you to subscribe to our channel so that you can also support us during this time when we are trying to be able to offer free lessons for you so that you learn when you are at home. Thank you very much.